Okay, so last week, like I said, we already started with simplification and multiplication and division of rationals. Remember that? This week, we're starting with addition and subtraction. Oh, not multiplication and division. We already did these two. So, our objective. Oh, sorry. I can add and subtract rational expressions. Let's read it together. 1, 2, 3. I can add and subtract rational expressions. So like I said, we already did multiplication and division. We're starting with addition and subtraction. Okay? We already know what rational expressions are. I give you guys examples, non-examples. But we need steps. Okay? Write these down, please. It says steps. Number 1, identify the common denominator. Identify the common denominator. In parentheses, if common denominator. So all you have to do is identify it, okay? So if it has a common denominator, I'm going to step 2. You just add and subtract the numerators by combining like terms. Add or subtract the numerators by combining like terms. Now check this out. Look up, please, really quick. From here, if they have common denominators, we add or subtract the numerators, bless you. I go to step 4. Everybody look up. I'm going to factor completely, bless you, the numerator and denominator, which is pretty much what we've been doing by simplifying. And then we just simplify by dividing out GCF. Okay? The blue part, step 3, that's if we add or subtract with uncommon denominator. So we would go from here. Identify common denominator. If not, we go here. Identify uncommon, simplify each fraction if they don't have common denominators. Then we do, bless you, then we do this step, step 2. Then we go to step 4 and then step 5. See what I'm saying? Okay, copy that, please. So here go the steps again, just to make sure we got it. Identify common denominator. That's if it has a common denominator. From there, we add or subtract the numerators by combining like terms. From there, we go to step 4. We factor completely the numerator and denominator. And pretty much we just simplify the fraction. Are we there? However, if we have uncommon denominators, I simplify each fraction first. From there, I go to add and subtract the numerators by like terms, and then I go to step 4 and step 5. Are you with me? Okay. So now, let's do an example just to see how it looks like. Here we go. Copy this one down, please. Example 1. Add and simplify your answer. 2x over x to the 4th plus 4x over x to the 4th. Okay, so I'm going to do this one first, okay, and then I'll have you copy right after I do the step. So step 1, identify the common denominator. What's my common denominator? X to the 4th, and I write it now as one fraction. Step 2, add the numerators by combining like terms. What is 2x plus 4x? 6x. Step 3, factor the numerator and denominator. This becomes 2 times 3 times x over x times x times x times x. Identify your GCF. What's my GCF? X. So therefore, this is 6 over x cubed. Copy that. Ready? Be nice. Example number one. I'm sorry. Example 1B. I was going to say number 1B. Example 1B. Copy this down, please. We got m squared plus 2m over m plus 4 plus 3m plus 4 over m plus 4. Okay? So, let's do this together. Let's identify our common denominator. What's our common denominator? M plus 4. We write it now as one fraction, and we're going to add the numerator by combining like terms. Let's see. M squared, are there any others? No, I write it, m squared. 2m plus 3m, that becomes 5m, and then at the end plus 4. Do we know how to simplify these kinds? Yes, so now we need to factor completely. This is open to parentheses. Denominator stays the same. Let's see. This is 4 and this is 5, m and m. What are my factors? 1 and 4. So this is m plus 1, m plus 4. Do you see the GCF? Which is this one. So we're left with m plus 1. So far, so good? Okay, let's do another one. Example 1C. See? Okay, here we go. Here we go. All right. Add 3k minus 18 over k squared minus 16 plus 6 over k squared minus 16. See if you can do that one by yourself. Go. Here, back, please, and stop hitting them on the back, please. Here we go. All right. Step 1, identify the common denominator, which is k squared minus 16 over, and now we have to add the numerator by combining like terms. 3k minus what? 12. From there, we need to factor both the numerator and denominator. So let's see. GCF for the numerator. 3, we're left with k minus 4. Look at this one. Isn't it a binomial? Is it subtracting? Let's check to see if it's a difference of squares. Square root of k squared is k. Square root of 16, that's 4. Therefore, since I was able to get the square root and it's a subtraction, therefore it's difference of squares. So I write k plus 4, k minus 4. Identify the GCF. What's my GCF? K minus 4, and we're left with 3 over k plus 4. Hands if you got that. Okay? Do another one. Example 1D. 1D. There it is. Copy that one. And this is 1D, sorry. It's 3y squared over y plus 1 plus 3y over y plus 1. Go ahead and find me the sum, please. Okay, here he goes again. Now, guys, make sure you go step by step, because if you're skipping steps and you want to go a little bit faster, if you don't see it, you're going to make mistakes. So here we go. Identify the common denominator. What's my common denominator? Y plus 1. Now we have one fraction. I add the numerator by combining like terms. Can I combine anything? No. So this is 3y squared plus 3y. Step number 3, or the next step, factor completely the numerator and denominator. So what is GCF for the numerator? 3y. We're left with y plus 1. What's in the denominator? Y plus 1. Do you see the giant 1? Yes. So we're left with 3y. Hands if you got that by yourself. Okay. Let's do another one. Copy this one. And this one is example 2. And now we're going to get into subtraction. Subtraction. Okay. Copy that, please. It's 6, bless you, 6y minus 6 over y squared plus 4y minus 12 minus y plus 4 over y squared plus 4y minus 12. All right. Step one is the same. Do we have a common denominator? Yes. So pretty much I just write y squared plus 4y minus 12. However, now I need to combine like terms, but now we have subtraction. The only caveat for this one, the only thing you need to remember when there is subtracting, since this is a binomial, that means the negative needs to be applied to both terms. To both terms. Tell your neighbor what I just said. So therefore, check this out. I'm going to rewrite this. First thing, I'm going to rewrite it here. 6y minus 6. However, what is negative times positive y? That's negative 1y. Are we there? What is negative times positive 4? Negative 4. Everybody see that? Now we can combine like terms. Let's see. 6y minus 1y, that's 5y. Negative 6 and negative 4, that's negative 10 over y squared plus 4y minus 12. Copy that, and then I'll go over the next steps. All right, so once we get to this point, the next steps are the same. Factor the numerator and denominator completely, and then divide out any GCF. Are we there? So here we go. So what's our GCF for the numerator? 5. And we're left with y minus 2. The denominator, we can factor and make two factors out of it. Factor the first term, y and y. I get my Power Rangers. Got negative 12, that's 4. What factors of negative 12 add or subtract to 4? 6 and negative 2. So this becomes y plus 6, y minus 2. You guys see the GCF? Yeah, y minus 2, y minus 2. We're left with 5 over y plus 6. So once again, the only thing that changed when we're doing subtraction is the fact that the subtraction needs to be applied or distributed to both terms of the binomial on the right side. Okay? To another one. Example 2a, I believe. 2a. 5a plus 2 over a squared minus 4 minus 2a minus 4 over a squared minus 4. See if you can do that one by yourself. Go. Okay, let's see. Step 1, identify common denominator. It's a squared minus 4. Now, I need to add the numerator by combining like terms. However, it has a subtraction. With that, I need to distribute to the second term. Is that correct? The second numerator. Times this and times this. So I'm going to rewrite this. 5a plus 2. This becomes minus 2a plus 4. Now I can combine like terms. 5a minus 2a becomes 3a. 2 plus 4 becomes 6. I bring this over. Now I can factor completely. What's my GCF for the numerator? 3. I'm left with a plus 2. This looks like difference of squares, so therefore I get a plus 2, a minus 2. My GCF is a plus 2, so we're left with 3 over a minus 2. Hands if you got that by yourself. Okay, not bad. Okay, so that was 2a. Let's do another one. Copy this next one down, please. (2b), and it's 2b plus 14 over b squared plus 3b minus 4 minus negative 2b plus 2 over b squared plus 3b minus 4. See if you can do that one by yourself. Go. All right, let's see. Let's see if you saw the curveball coming. Identify the common denominator, which is b squared plus 3b minus 4 over combined like terms on the numerator, but we have a negative right there, don't we? This times that, that becomes plus 2b minus 2. I bring this down, 2b plus 14. Combine like terms, 2b plus 2b becomes 4b. 14 minus 2 becomes 12. B squared plus 3b minus 4. Now we can factor completely. What's our GCF here? 4. We're left with b plus 3. This one becomes, let's see, b and b. Orange got negative 4, 3. What are my factors? 4 minus 1. 4 times negative 1, yep. So this is plus 4, b minus 1. Can we simplify anything out of this? No. So we're done. Okay. Do another one? Yeah, since there are no GCF or from there, we're done. Okay. Do another one. Copy this one down, please. Example 3a, and you're going to write find the LCM of the given expressions. You're going to write 12x squared y, comma, 9xy cubed. Copy that, please. And we'll do that one together. All right, here we go. The 12. Prime factor that divides 12. Which one would that be? 2. Okay, 2 times 6. So the 2 is a prime. How about this one? 2 times 3. And these two are prime. And then let's factor out the x squared. This is x times y. Look at the 9. 9 is 3 times 3. Let's factor out the variables. X times y times y times y. So let's identify our GCF. What's our GCF for these two? 1, 3. 1, 3. So there it is. And 1x and 1y. 1x and 1y. So x, y. Okay. What's left for this one? Let's look at this one. We're left with 1x and 2, 2. So this is 4x. Is that correct? What's left over here? The 3 and y squared, so we write 3y squared. So my LCM, we just multiply all the way across. Let's see, 4 times 3 times 3, 36. X times x, x times x, x squared, and y times y squared, y cubed. Are we there so far? Okay. Now, for some of you, Ty, that you just want to go from here to identifying your LCM without doing this, you're good. I'm just using this tool so that we can keep organized, because right now we're going to get into polynomials, and if you don't see it, just use this tool. Okay? Let's do another one. 3b. Copy this one. C squared plus 8c plus 15 and 3c squared plus 18c plus 27. I know, huh? They're cool. Okay, let's continue. Here we go. Let's do this one together. So let's find our, guys, let's find our prime factors for this one. Is there a GCF? Nope. So we open two parentheses. Power Ranger. Let's see, 15, that's 8. What factors of 15 add up to 8? 5 and 3, and I say 3 and 5. So therefore my factors are C plus 3, C plus 5. So these are my prime factors. Now let me go to this one. What's my GCF? 3. I open a big parentheses and we're left with C squared plus 6C plus 7. Should we factor this one to find my prime factors? Oh, plus 9. I did that on purpose to see if you were paying attention. All right, so therefore, we got 9 and 6. What factors of 9 add up to 6? 3 and 3. So therefore, C plus 3, C plus 3, and I bring down the friend. So now check this out. I'm going to use my Venn so I can keep organized and I can see it, because some of us still don't see it. What's our GCF here and here? What's the same? C plus 3. That goes in the center. C plus 3. What's left for this polynomial? C plus 5. And what's left for this one? 3 times C plus 3. Does everybody see it? My LCM, we multiply everything across this way. And let's just leave it as factors. How about that? So I'm just gonna write it out. What's my first factor? C plus 5 times C plus 3 times. I'm gonna write the 3 over here in the front. Everybody look up. Instead of writing the 3 here, I'm gonna write it here as a leading factor, and then I'm just gonna write C plus 3. Yes? What? Yeah. If you wrote 3 times C plus 5 times C plus 3 squared, yes, I'll take this also. Yes. I would take either answer, this one or this one. They're both factored all the way. It's all the way. Oh, no. Just leave it factored. Yeah.
Oh, you put it factor?
Yeah. Yeah, because then you're going to end up with the same thing you started with. Okay, let's do another one. Copy this one. Does everybody see how to use the tool if you don't see it? Yeah, right? Isn't it easier to see like that? Yeah, that's Mr. Cube. All right, let's do another one. Copy this one, 3A. Do that one by yourself. Yeah, example 3A.
It's actually example 3.
Oh, 3C, my bad. All right, example 3C. You guys see? Okay, so this is 5F squared H and 15FH squared. Find me the LCM, please. Go. Okay, here we go. See what you got. This one's already, it has its prime factor, which is this one, but I'm going to factor out the F squared to F and F times H. This one, 3 times 5, F times H times H. Are we there? So my Venn goes like this. I'm going to identify my GCF. What's the same here and here? 1, 5, 1 F, and 1 H. So therefore I write 5 F H. What's left for this one? F. What's left for this one? 3 H. And now I just need to multiply all the way through. 3 times 5, that's 15. F times F, that's F squared, H squared. Hands if you got that. Okay? And that's my LCM. Okay, so now we're done with the easy part. Let's go to, not that one. Copy this one, please. Example 4A. 4A. Add or subtract. However, look at this one. This one does not have like denominators. Okay? So this is 2n over 5n cubed plus 4n over 2n squared. No, I'm going to show you. Okay, here we go. Pens down, eyes up here. So now, this one. In order for us to have a we need to identify the common denominator, which it does not have. Therefore, we start with factoring the denominator. If we look up, this one becomes 5 times n times n times n. This one becomes 2 times n times n. So, what does this one have that this one does not? A 5 and n. So we need to multiply this side times 5n times 5n. However, what does this one have that this one does not? So this is times 2 times 2. Are we there so far? So now check this out. So what would be my common, everybody look up please. What would be my common denominator now? 2 times 5, that's 10n cubed. And what's in the numerator? 2 times 2, that's 4n plus 5 times 4, that's 20n squared. Copy that, please. Okay? From there, we need to simplify this fraction. Look at the numerator. Is it in standard form? No, we need to rewrite it. This becomes 20n squared plus 4n over 10n cubed. What is my GCF for the numerator? 4n, and we're left with 5n plus 1. We bring this over. Bless you. We got 10n cubed. However, what are my prime factors here of 4? 2 times 2. Prime factors of 10. 2 times 5, and the n cubed can be written as how? N, n, and n. Are we there? So check this out. 1, 2, 1, 2. 1 n, 1 n. So what do we have in the numerator? 2, 5n plus 1 over, what's left here? 5n squared. And we're done. So, I know it's easy, right? Homework is found on page what? 663, numbers 1 through 31 odd. Have a good one, guys. Enjoy your homework. I'll see you guys tomorrow.